and I'm going to expand that second set of brackets as well. So we're going to have 2n minus 2. Now, again, we might tidy this up. I'll cheat and use my eraser. I know that 30 take away 2 is just going to be 28. So I can write it as such, okay? And then I'm going to have 28n over 2 and 2n squared over 2, which again is all going to simplify down to 28 plus n squared. Now, if you wanted to get your answer from there, what we're trying to do is get n on its own. So we've got a little equation to solve. We might just bring it up over here. So if I was to get n squared on its own, I want to move this 28 over to the other side. Okay, I'd do that by taking it away. I'd get n squared equals 131, just like that. And then to get my n, that's going to have to be the square root of 131. Now, generally when we do equations, we've got to consider it could be the positive square root of 131 or the negative square root of 131. Now, it doesn't really make sense to have a negative number of rows. It doesn't click with the problem, which is why we're going to get rid of the negative. Okay, so it's just going to be the square root of 131. Now, if you type the square root of 131 into your calculator, you get an answer of 11.4455 blah, 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 blah. Okay, because it's a surd, it's not going to round to a nice number. So just to answer our question, let's go back to what it actually asked, is given these numbers and what we've solved to find n, it's saying how many rows are required for a shot with that many students. Now, obviously 11.45 or 44 rows isn't exact. It doesn't make much sense, and you're not going to have half a row. So we're going to have to round up here to the next whole number, the next whole row, because otherwise we can't fit all of those students. So that's where understanding the story of the question is really important. So what we're going to say here, we're going to finish off and say, therefore, we're going to need 12 rows to fit 159 students. Okay, just to recap what we did there, we took our A, our D, and our answer. We popped it into the yucky formula. All we did on the inside, which I assume is if you're lost where I lost you, is we just simplified, so expanded the brackets, okay, just by multiplying through. Then we multiplied through from out the front. So again, just expanding by multiplying that by both parts. You can see that n's are going to be cancelling. N's are cancelling and 2's are cancelling. And then we've just got a nice little equation to solve in terms of n. You get rid of a squared by square rooting. That's going to happen a lot with these kind of setups. And again, we got rid of the negative because it didn't make sense to have negative rows. Okay, so that was part B, and we are just going to erase that so we can work on the next example. Okay, so now we're going to work on what is quite a deceptively tricky question. It's kind of the hallmark of Arithmetic Series. There's lots of variations of this if you Google this question. So it's saying find the sum, so that's how we know it's a series, of the multiples of 7. Now, when we get to geometric sequences and series, that whole idea is that you're multiplying each term by the same number. We're going to get to those. So you might be tempted when you see multiples to think, no, that's a geometric instead of an arithmetic. But what you need to think about is, if I was to break this up into terms, my first multiple of 7 is 7. Next multiple, it's just my times tables, is 14, 21, 28, and so on. So you can see it's actually arithmetic because all I'm adding each time is 7. Okay, and so we're doing that, finding the sum, so adding all those together, between 100 and 200. Now that's what makes this question really, really tricky, all right? Because we're trying to find the sum between 100 and 200. If I was just doing 1 to 100, it wouldn't be too bad because I have the first term there. I just need to find the last term and I could go for it. Or I could even just find the difference through that method as well. So instead, what we're going to do is we need to look at this between 100 and 200 and figure out, well, what is the smallest multiple of 7 that I can have? So the closest to 100, and the largest, so the closest to 200. The way that I'd be doing this for myself is just to say, well, what's 100 divided by 7? In other words, how many 7s go into 100? Now, we could do this using short division, but why waste our time? Instead, we get an answer of 14.285, blah, 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 blah. Now, what that tells me is, and you can check it for yourself, that if I was to type in 14 times 7, that's going to be a little bit too small, all right? Because 100 is a bit over 14. And that's right, because 14 times 7 is going to be, I think, 98. Yes, 98, okay, which isn't between 100 and 200. And I'm looking for the smallest multiple of 7 that is. So it must be the next one. It must be 15 times 7. So if you were to type in, or I suppose just add a 7 onto that answer, 15 times 7 is 105. So that is the smallest multiple of 7 between 100 and 200. Now, because that's the range we're working within, that must be my first value. So it's my starting value. That's my A, is 105 for this question. Okay? So then I need to find, using the same method, the biggest value, biggest multiple of 7 between 100 and 200, so closest to 200. So again, I'd go 200 divided by 7. Again, just chuck it into your calculator. Divided by 7, you get 28.57, blah, 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 blah. Now, if you weren't too sure, what you could do is you could type in, okay, well, what's 28 times 7? That's 196. And you'd go to yourself, okay, cool. That must be the biggest multiple of 7 because it's under 200. It came out nicely. And if I was to do 29, I'd clearly be over. I'd be at 203. So what that's told me is between the domain, the range that I'm working between, I have the smallest value of 105 and my largest value, which I'm going to write with L, is 196. And I'll highlight that one as well, just so that we're really clear on that. So now what I found is my smallest value and my largest value. And if we go to our reference sheet, I'm setting myself up to use this really nice short formula where it's the number of terms over 2 times the sum of the first and last numbers. So I already have the first and last numbers. What I need to know though is the sum of, or the number of terms. Okay, so what I need to know is, well, what number term is this 196? Okay, so the way we're going to figure that out is by using the term formula, because that tells me what number term, like we did with questions before. So all we're going to do for this to find n, I'll do it in blue so you can kind of see that we're working on something different. To find n, I want to say, well, what am I going up to? So when I get an answer of 196, and again, I'm popping 196 as my term, where A is 105 from just here, okay, plus, now it's going to be n minus 1, so I'm going to keep that as n minus 1, times my difference. Now my difference, come back to this example that we started with, this would just be the basics. Multiples of 7 or multiples of 5 or multiples of 3, whatever you're doing, just means that you're adding on that number each time. So my common difference is just 7. Okay, so now what I want to do here is solve for n to find the number of that term. So the way we're going to do that is we're going to have to subtract across this 105. And I'm going to rewrite this a little bit too. I'm going to pop this 7 just out the front. and swap the sides, just because that's kind of like how I like to work. And if I was to take 105 away from 196, I believe I'd be left with 91. And then what I need to do is get rid of this 7 by dividing him across. Now 91 divided by 7, it does come out nicely. It's 13. It's always a good sign when that step, when you do a division, comes out nicely. Finally, I need to get that 1 across, so I'm going to add him, and I get n equals 14. That tells me that this 196 is my 14th term. Okay, so now what I need to do is I need to, and in case you're wondering, well, that doesn't make sense because it is quite abstract. The reason I get 14 and not like 28, because it was the 28th multiple, is because I used my A value as 105, which was the smallest value within that domain. So by popping in those values as like my first and my difference is 7, that's why I get the number of terms being 14. It's starting at 105. Okay, so now I know that n is 14. I have everything I need to pop into this really nice formula. So I'm going to write it just over here. Now I know that n is 14. So S of 14, the sum of 14 terms, where it's going to be, n over 2. So 14 over 2. And we multiply that by the first and last added together. So 105 and 196. Pop that straight into your calculator. 105 and 196. And we get 2,107. Okay, so a deceptively tricky question considering it's quite short. You could do that with any range of numbers, so between 100 and 1,000 or 1 and 5 million. Right? Obviously you wouldn't because the numbers would be too big.